In the last video, I explained how to read from the memory and how to write to the memory. But at that point, we hadn't connected the memory to the bus. Now we need to connect the memory to the bus so that we can store the results coming from the ALU and also send data from the memory to registers R1 and R2. By the way, in all previous discussions, we didn't connect the ALU output directly to the bus. And instead, we were just displaying the ALU output using some LEDs. Let me show you this on the circuit. This is R1, this is R2, and this is the ALU. R1 and R2 are connected to the bus through these 4 lines for R1 and these 4 yellow wires for R2. But if you look at the ALU, you can see that there is no any connections between the ALU and the bus, and that is what we need to do today. We need to connect the ALU to the bus and the memory to the bus, okay? So we have a problem here because the bus consists of 4 bits or 4 lines, but the ALU output consists of 5 bits as you see here because we have the last one is called the carry out. In this course, I'm going to focus on the lowest 4 bits and I'll neglect the carry out. The reason for that is I want to simplify the circuit as much as I can. So I'm simplifying so that you can build this on your side. But if you want to implement something that deals with the 5 bits, you need to do this in 2 steps. We cannot send 5 bits of data using 4 bits bus in one cycle or in one step. You need to send the lowest 4 bits in the first step and the last bit in the next step or the next cycle. That is what you need to do. But this is out of our focus today, okay? So let's start with the ALU connection to the bus. We need to connect 4 bits here from the ALU to the bus. And we know that the output here is represented by these 4 LEDs. So I am going to connect some wires from these LEDs to the bus. Let me do this. This is the first connection. I know that this circuit will not work because we have a serious problem here, but I want to show you the problem and then we can solve the problem after that. You might wonder why we are connecting the last line from here, not from here. The answer is easy because this LED is already connected to this pin here using this blue wire. So now we finished this connection. We need to connect the memory also to the bus. So I'm going to take 4 wires from the memory to the bus. But the problem here is the memory that we have here, 74LS189, has 3 different parts that we use for the operation of the memory. Let me show you this here. This is the memory IC, and as you see, one second. As you see, we have 4 bits for the address, starting from A0 on pin 1, A1 here on pin 15, up to A3 on pin 13. I want to ask you a question here. Do we need to connect the address bits or the address pins to the bus? The answer is no, because the address comes from the memory address register. So these 4 bits from A0 to A3 should be connected to the MAR, not the bus, okay? So I'm going to neglect the address bits. Then we have another 4 bits starting from D1 up to D4, and these pins are used to store data into the memory. So if you are, let's say for example, you have a result here on the ALU output and you want to store this into the memory, then you can use these pins here from D1 to D4. And finally we have the O. the O outputs, starting from O1 to O4. These pins are used to read from the memory. So if you are sending data from the memory to R1 and R2, then you need to use O1, O2, O3, and O4. So the question here is, which pins should be connected to the bus? First of all, let me take one step. We have two directions here to send the data, from the ALU to the memory, or from the memory to R1 and R2. Let's take the second one, from the memory to R1 and R2. And here I want to ask you, if we need to send data from the memory to R1 and R2, which pins here we should use? We should use O1, O2, O3, O4, because these are the pins that we use to read from the memory and send what we read to the R1 and R2, okay? So we need to focus on O1, O2, O3, O4. We know from the last video that these LEDs represent the output, O1, O2, O3, O4. I'm not going to explain this again. Please watch the previous video or the last video. So I need to put some connections from these LEDs to the bus. I'm going to do this to here. So now we finished this connection and this connection. Let's say, for example, we need to send data from the memory to R1. This is R1 and this is the memory. R1 is connected to the bus and the memory is connected to the bus. So we need to take the data from here through the bus to here, right? So how can we do this? Let's start by connecting the power supply. So this is our power supply, VCC and the ground. As you see, the circuit lights up, but this is not how it should work. Let's look at the memory. First of all, we need to read data from the memory and send them to R1, right? By the way, you can notice that the circuit is not stable, right? But anyway, let's start from the memory, and as I mentioned, let's say that we need to store data in the first address, and these bits control the address. These bits are used to store the data into the memory, and the LEDs are used to display the data that we read from the memory, and this bit here is used to trigger the write or the read. If it is switched off, if it is turned off, then we are writing. If it is turned on, we are reading. But the thing that you can see here, that the circuit is not stable at all, and I'm going to explain why, okay? So now we need to write, let's say 1, 1, 0, 0. And because the right switch here is connected to the ground now because it is turned off, then the first address here, the first address in the memory should contain now 1, 1, 0, 0, okay? Let's read the data of the first address. We should see 1100 here on the LEDs if we turn this switch on, because if you turn it on, you are reading. But as you see, it is not, these LEDs are not on. Why? Because we have a problem in the bus. As you see, the ALU outputs are connected to the bus here. The memory output are connected, the memory pins are connected to the bus here. And also, if you remember this switch, these switches are connected to the bus. By the way, these switches are used to input data to R1 and R2. So the data from our previous discussions, we were taking the data from here to R2 or from here to R1, right? But because we are talking about moving the data from the memory to R1 or R2, we can remove these switches. We don't need them, okay? But yeah, let's remove them. We don't need them. But there is a problem. We still have a problem, okay? Now, again, we write to address to the first address 1100. When we read, we should see 1100, but this is not what happened. Why? because as I mentioned, these pins are connected to these pins, and you cannot connect them together like this. Because let's say that the ALU has now 0, 0, 0, 0 on the output, and as you see, they are these LEDs are zeros, right? And we are outputting data from this memory, this IC, to the bus again, to the bus also. So we are getting zeros from here and 1, 1, 0, 0 from here. Do you know what happens if we connect 0 to 1? Do you know what happens? This is similar to if you get the power supply and connect the positive to the negative. You should see a fire, right? So, but because this is the output from the IC and this is the output of the memory, the output of these ICs has like very low current. That's why we do not see a fire here. But if you do this on the power supply, for sure you will smell the burning of these wires. Okay, so now you understand the problem, and again the problem is the output of the ALU is connected to the bus and the output of the memory is connected to the bus, and they are connected together, and that is wrong to happen. So what is the solution? The solution is to do some isolation. So if you want to move data from here to R1 and R2, then isolate the ALU from the bus. Isolate means just remove the wires, okay? Or make the wires open circuit. You can put some switches here to make these wires open circuit. And if you want to send data from the memory to the from the ALU to the memory, you can do this by disabling these wires. You might ask, if we remove these wires or disconnect them, if you disconnect these wires, how the data will be moved from the bus to the memory? The answer is very easy. Do you remember these bits? If you are storing to the memory, you should not use these. These are the output of the memory. If you want to write to the memory, remove these switches and connect other 4 wires here, so the data can move from here to this and from this to the memory. I hope that you understand this. I know that it is a little complex, but if you feel like confused or something, try to watch the video again and again. So we know that this is wrong, so I'm going to remove these connections and see how can we make open circuit here and open circuit here, because we need here 0 or 1 or open circuit, and from here we need 0 or 1 or open circuit. 0 or 1 depending on the output that we get from the memory. 0 or 1 depending on the ALU output, and open circuit if we are moving data from other unit, and this should be open circuit if we are moving data from other unit, and etc. Okay, so let's remove these connections, and let's see what we should do here. We need something called tri-state buffer. Let me show you how the tri-state buffer works. The tri-state buffer, from its name, tri-state buffer, sometimes it is called 3-state buffer, and it's called tri or 3 because it provides 3 states: 0, 1, or open circuit or high impedance. Okay, so, and it is called buffer because it's just buffering the data. It's just delivering the same data that it takes on its input. So let's say the input is 1, the output will be 1. The input is 0, the output will be 0. Just if you enable the IC, if you enable this IC, okay? So it is called the tri because we have 3 states, and it's called the buffer because it just delivers the input to the output. And its layout looks like this. This is called enable, and we have here a transistor as a switch. I hope that you remember how the transistor works as a switch, okay? And this is a connection to the base, and this is to the VCC. Okay, so this is our input, and this input can be 0 or 1, and this is, let's say this is output A, and this is our real output. This is the final output that we get, okay? This is the output. Let's now build a truth table. This is our output, this is our input, and this is the enable. So let's say 0, 1, 0, 1, 0, 0, 1, 1. By the way, let's consider that this is active low. What do we mean by active low? It means that this switch will be on short circuit if we connect here the ground. And if you connect high or the VCC, the circuit will be open circuit. So let's take the second one, the second case. The second case, this one is connected to the VCC, which means the circuit is open. I want to ask you, if this circuit is open, what the output should be? It should be 0 or 1. Actually, it shouldn't be 0 or 1. It should be high impedance because it is an open circuit. So it is connected to nothing. It's connected to the air, and the air has high impedance. That's why we come here and say if the enable is 1, this is called high impedance, high impedance. And by the way, sometimes they refer to the high impedance with Z, okay? And if the enable is 0, that means that this is short circuit, okay? And in that case, if this is 0, the transistor will be open circuit, meaning there is no current here, and that means that this is the output here is connected, almost connected to the ground. So it will be 0. If we have here 1, so this will be short circuit. That means that the output is connected to the VCC. So this should be 1. So if you look at the input, it is exactly similar to the output. So that is why it is called the buffer. So that is the truth table, and that is how it works. And that is exactly what we need. Again, this is the ALU, right? If we need to take output from the ALU and store it in the memory, then we can use enable equal to 0, right? Enable equal to 0. In that case, the output will be 0 or 1, and this data will move from the bus to the memory. But if we are moving data from the memory to the registers, for example, then we need to disconnect the ALU from the bus, not to confuse the bus that in this case, because it takes data from different units. So in this case, we connect the enable here of the IC to 1. That means that the ALU is totally disconnected from the bus, right? That is good. Let's now look at the ICs that we use as a tri-state buffer. We have 2 of them. The first one is called, has a number of 74LS245, and the second one, let's see, where is the second one? Yeah, the second one here. The second one here is 74LS244. There is a difference between them, but there is also a similarity between both. Both are octal, and octal means 8 bits. So each of them has 8 bits as input and 8 bits as output, okay? And it is called the 3-state buffer, as we mentioned. We know that now, and sometimes it's called line driver or line receiver or transceiver. So they are, all of them are meaning the same thing. Let's focus on the 245, and this is how it looks like. As you see, we have some inputs here starting from A1. I hope that you can see this. Starting from A1 to A8, and the outputs are from B1 to B7, to B8, sorry. And we have pin 10 should be connected to the ground, pin 20 should be connected to the VCC, and this is the enable. Do you remember the enable that we explained? And the direction. We have a pin called direction because we can move data from here to here or from here to here. We are going to use one direction, so I'm not going to focus on this. So let's just see how the direction or what value should we connect the directory to, or the direction to. So if you connect the direction control pin to low, then you are moving data from B to A. If you connect it to high, then you are moving data from A to B. We need this one. We need the second one, from A to B. That's why the direction should be connected to the VCC. Remember that because we are going to implement this connection after a few seconds, okay? And then VCC, the enable. Do you know which value should we connect the enable with? we should connect the enable with to either 0 or 1 depending on the state that you want. You can connect enable to high if you need to isolate, to disconnect the unit from the bus. You can connect the enable to low if you want to move data from A to B, from A to the bus, okay? So this is our IC. I don't know if you can see the number. Let me see. If you can see the number, it's okay. It is 245, and I'm going to connect this IC here. That is good. And again, this is pin 20. This should be connected to the VCC. Pin 10 should be connected to the ground. The direction pin should be connected to high so that we can move data from A to B. If you look at the first pin here, I connected this pin to the VCC. These are the main connections. Now, this is 8 bits, but we need 4 bits only because our design is a 4-bit CPU design. So we can only use these 4 bits and just neglect the other 4 bits, okay? So we need to connect A1 to the first output here, A2 to the second output, and so on. Let's do that. So this one should be connected to the second pin here, pin 2. Let me revise this. Yeah, A1 is on pin 2. And then the next one to the next pin. It is very easy. And by the way, after we test the board, I am going to remove these wires and just connect shorter wires like this to make this circuit looks better than this. And then here, yeah. So now we connected the inputs. Let's now connect the outputs to the bus. So I'm going to connect B1 from pin 18 to the first bit on the bus because this is B1, so it should be the first one on the right. B2 should be the next one, and so on. So I'm going to take the output from here. B1 is on pin 18, not 19. 19 is the enable. So this is 20, this is 19, and this is 18. So from 18 to the first one here, let me bring some shorter wires here. So pin 18 to here. The next pin to the second one here. The next one. And finally we have the last one here, this one to this, okay? Yeah, make sure that you connected the wires perfect. So if you don't do so, the circuit will not work and you will spend too much time on troubleshooting the circuit, okay? So now we finished this connection. For the first time, we finished this one. Let's work on this one. So I'm going to connect the second IC here. So it should be like this. I hope that you can see that. Let me zoom in and later on I'll zoom out. Okay. So again, pin 20 to the VCC. Pin 1 to the VCC also. This is the direction pin, and pin 10 to the ground. Let's now see what should we connect. We are going to use these 4 bits. A1, sorry, not this IC. A1, A2, A3, A4, pin 2, pin 3, pin 4, pin 5. And we should connect these pins to the LEDs here because we are taking the output of the memory, and we know that these LEDs represent the memory output. So I'm going to connect these LEDs to these 4 pins here. So the first LED to the first pin here, the second LED to the second pin, Now we should connect the other side to the bus. So let's do that. So this is the first one to the bus. This means that we finished this connection and now we can test our circuit. But let me zoom out. So I hope that I don't forget this. Okay, let me zoom out a little bit again. Okay, yeah, so this is our circuit now. What we need to do is to test the circuit. So I'm going to connect the VCC and the ground. This is the VCC and this is the ground. Yeah. Let me close this and close these switches, and let's now see how can we start. First of all, you can see that I removed the switches from here because I am going to send data from the memory to the registers, not from the switches to the registers. Is it easy for you? Anyway, if it's not easy, just give me a comment in the video, and I'll try to explain this more. So let's start storing some data in this memory. So we need to store 1100. Now the data is stored in the memory because we enabled the write by connecting it to the ground. If we click here to turn the switch on, we should see 1100. So let's do that. Do you see 1100? That's correct. By the way, I forgot to connect the enable pin of this IC, and the enable pin is on pin number 19. So let's connect any wire from pin 19 to the ground. So what do we have here now? We have this IC works as a short circuit because we connected its enable to the ground, and we have this IC works as open circuit because we connected its enable pin to the VCC. That means that the ALU is isolated from the bus. It is disconnected from the bus, and the memory output is short-circuited with the bus, which means it is directly connected to the bus. So in this case, we can move the data from the memory to the bus and from the bus to R1 or R2. That is what we are doing now. We are moving the data. We will move the data from the memory to R1 or R2 or both of them. So how can we do this? First of all, you need to read data from the memory. Let's say, for example, we need to read address 1. As you see, address 1, this is address 1, right? So address 1 has a value of 0000. Let's store another value in this address. Let's write first, and then let's use this. When you do this, you are writing this value to this address. So again, you are writing to this address, you are writing this value to this address. So if we read now the same address, you should see 1100. Let's do this, 1100. So it is very easy. Now let's trigger the registers to move the data from here to R1 and R2. And again, this IC is short-circuited now. That means that these wires are connected to the bus. So the memory output is connected to the bus. Let's trigger the first register, 1100. Trigger the second one, 1100. And the 3 plus 3 is equal to 6. 0110. Alright, so we need to try another value. Let's read from address 1. Address 1 has a value of 1011. This is by chance. I didn't store this value. And because you didn't store anything, so the value will be any random value, okay? So now let's trigger the IC here. As you see, 1011 like this one, and we can trigger the second one to get a different value, okay? That is good. You can try other values. I'm not sure if we can get different values. Yeah, 1110. So let's trigger the IC, 3 ones and 0, 3 ones and 0. Now let's do something different. Let's move the data from the ALU to the memory. We already now know how to move the data from memory to R1, from the memory to R1 and R2. Let's do something different. Let's move the data from the ALU to the memory. How can we do this? First of all, you need to connect the ALU to the bus. But before doing this, disconnect the memory output first. Okay, so put this on the high impedance. So that means that the output now, the memory output is not connected to the bus. It is disconnected from the bus. So we can now enable this IC, which means the ALU now is connected to the bus. So we can take the data from the bus and store it into the memory. But there is a problem. Let me ask you a question here. Can we use these 4 bits or 4 wires to store the data into the memory? The answer is no. Why? Because let me show you the data sheet again. If you remember, for the data from the data sheet, we have 4 bits for the address, 4 bits D1, D2, D3, D4 to store the data into the memory, and another 4 bits O1, O2, O3, O4 to read the data from the memory. So if you are moving from the ALU to the memory, you should use D1, D2, D3, D4. If you are reading from the memory to R1 and R2, you need to use O1, O2, O3, O4. We already are using the O values here, so we need to use the D values. But let me make it easy for you. This is the address, and we do not need to change the address or connect it to the bus. We do not need anything like that. But these switches are used to store the data into the memory, which means these data are connected to D1, D2, D3, D4, and that's what we are going to do. I am just going to connect these pins, the red ones. Do you see the red one, D1, to the first line here, and the next one to the next line. This one okay, that is good. We can now move the data from the ALU to the memory, but there is a problem. The memory now has 2 connections to the same pins. So we connected the bus to D1, D2, D3, D4, and also these switches are connected to D1, D2, D3, D4, and that is wrong. I told you, you cannot connect 2 different connections without isolation. So I am going to remove the switches because we do not need the switches now. We put the switches here because we didn't have a connection between the ALU and the memory. We are just assuming that this one works as an ALU. So now we do not need these switches, so let's remove the switches from here. And also you have to remove the resistors because they are connected to through these connections. I can remove these wires also, but let's keep them for now. We might need them. Let's now turn the circuit on, connect the power supply, and as you see we have 0, 1, 1. This is from this address. Let's go back to address 0. Address 0 now has 1, 1, 1, 1. You might say, oh, it was 1, 1, 0, 0. Yes, but you disconnected the power. When you disconnect the power, this is called a volatile memory. It erases all the data and it can take another random data. So let's now get any other address. Let's say this this value, and let's trigger the register. But before triggering the registers, what we need to do here is to just put some values on these registers to get some output here, to get any value here, because now the output is 0. If you store the value, you are storing 0, so nothing here to do. So I am going to disconnect this from the VCC and connect it to the ground, but before this, put this on the high impedance, put this on the ground, and now trigger the registers, okay, and this one. So we have 0, 1, 0, 1. I am neglecting this, okay? I already said that. So now let's store this value to, let's say, address 3. So this is address 3, okay? So I am going to disconnect this and connect it to the VCC. This is to the ground. This means that the ALU now, because we enabled this IC, the ALU now is connected to the bus, and the memory output is disconnected from the bus. So what we need to do now is to move the data from the ALU to the bus, and from the bus through these 4 wires to be stored in the memory. So what we need to do is to just write in the memory, but let's write in address 2. This is address 2, right? So let's write. How can we write? By turning this switch off. So I'm going to write. That's it. That's all you need to do. You might say, oh, these bits are zeros. Yes, that's right, because we are writing. If you want to make sure that the value that we stored similar to this value, you can just read the value again. Yeah, we have something wrong here. Let's see what is the problem. Okay, so we have this 0, 1, 0, 1. And we have here 0, 0, 1, 1. Okay, let's try another value. We have here 1, 1, 1, 1. Let's write to address 0 and read again. Yeah, we are reading different values. So let's revise these connections to make sure that we didn't reverse anything here, because we have 2 here are on and 2 here are on, but they are different in different positions. So this is, let's see, this is the first one from here to here. This is the 4-bit adder. Let me revise. Where is the 4-bit adder? Yeah, this is the 4-bit adder. Where is pin number 1? This is pin number 1. That's right. So we need this one from, it should be from E1, right? So it should be from E1. Why we connected this one here? Yeah, it should, yeah, that's right, because E1, let's start with the E1. E1 from pin number 9. So we took pin number 9 to the first bit here. Okay, that's correct. Let's look at E2. Where is E2? Pin number 6. So where is pin number 6? This one. Yeah, do you see the problem? This one should be connected to the next pin, not the third one. To the second one, not the third one. So I'm going to reverse it here. Yeah, okay. Let's now write the value again and read the value to, yeah, so it works fine now. That is really, really good. And this is how to troubleshoot the circuit when you have a problem. Let's now try another value. Let's take this value and send it to the registers, and then take the output back to be stored in the memory. So I am going to disconnect. Let's connect this to the VCC to disconnect the ALU, and enable this to short circuit this IC in order to send data to the registers. So let's do this and this. Let's say that this is what we need, okay? We do not need to put the same value here. So let's now read the ALU output or store the ALU output into the memory. Again, what are the steps? I need you to pause the video and think about it, okay? I'm going to connect this here and connect this here. Now the ALU is connected to the bus, and we can move the data from the bus through these 4 wires to be stored in the memory. How can we store in the memory? Let's choose address 2. So address 2 has 0, 0, 1, 1. We are going to store 1, 1, 0, 1, 0. So let's store and read again. So it is 1, 1, again, 1, 1, 1, 0, okay? Let's try this for the last time. So we are going to connect this to the VCC and connect this to the ground. So now this means that the output here is connected to the bus. Let's move this from the bus to R1 or R2. Let's try R2, okay? And also R1, no worries. Now let's let's take the output of the ALU back to the memory. So let's disconnect the memory output and connect the ALU to the bus, and let's choose another address. So this address has 1011, and we need to store this value instead of this one. So we have this one to write and this one to read. So 0111, 0111. That's what we have. So this is how it works. Now we finished this part. We connected this part, We connected this part and we connected the memory, and we can move the data from the memory to R1 and R2 and also from the ALU to the memory. In the next videos, I'm going to work on other connections. Let's say, for example, maybe the MAR to the RAM, and after that we are going to work on the program counter and then the decoder and the IR. I know that we are spending too much time on this, but I think if you follow the same steps, you can implement this yourself. And that's all for today, and see you in the next video.